Hello and welcome to this e-content development program organized by Dr. Babasaheb Ambedkar Technological University, Lonere. I am Mr. Bhushan Gaikwad, working as an assistant professor at Sri Prakash Chand Jain College of Pharmacy and Research, Palaskede, 3 km away from Jamner, district Jalgaon, Maharashtra. Today I will discuss on the topic size reduction, its mechanisms and its laws. Initially, we will see the learning objectives. Upon completion of this session, the learners or students will be able to understand the concept of size reduction. Then the learners will be able to define the term size reduction. Then we will be able to explain the concept of monodispersity and polydispersity. Then we will be able to understand the advantages and disadvantages associated with size reduction. Then we will be able to explain the mechanisms of size reduction, and we will be able to elaborate various laws governing size reduction. So by keeping these learning objectives in mind, we will move on towards presentation. Initially, we will go for definition of size reduction. Here you can see the diagram in which you can see the larger particles are being converted into smaller one. So on the basis of which we can define the term size reduction. It is the process of conversion of large solid unit masses into small solid unit masses. Means simply conversion of coarse particles into fine particles. Synonyms which are alternatively used for size reduction are comminution, diminution, pulverization, milling, etc. So these are the synonyms which are used for size reduction. Dear friends, now here we will discuss the concept of polydispersity and monodispersity, which is very necessary to use here for size reduction. So here, what is the meaning of polydispersity and what is the meaning of monodispersity? If we are plotting the graph of particle size versus number of particles, then we will get the graph in this way. This is for polydispersed powder. On the other hand, if we are getting the graph in this way, this is for monodispersed powder. Means here simply you can see this graph is wide, while as this graph is narrow. Means polydispersed powder gives wide graph. Wide, its nature is wide. In case of monodispersed powder, its nature is narrow. Okay, means polydispersed powder are having a wide particle sizes. Generally, in pharmaceutical operations, the powders which use are polydispersed in nature. Means these are consisting of particles with different sizes. So therefore, these polydispersed powder should be converted into monodispersed powder, because if the powder is polydispersed, it creates much difficulties during production. So therefore, if the powder is polydispersed, it should be first converted into monodispersed. For that, size reduction is necessary. So this is nothing but the concept of polydispersity and monodispersity. Now we will move on towards advantages of size reduction. First, contain uniformity. To pass the test for contain uniformity, particle size of material should be small and uniform so that effective mixing can take place. So for this, size reduction process is carried out. In size reduction, larger or coarser particles will be converted into small and uniform so that content uniformity test can be attained. It is mostly applicable for potent and low dose drugs. Next, uniform flow. We know very well that small particles show uniform flow. So size reduction achieves this objective. Here you can see the animated diagram in which powder particles are flowing very easily. So this uniform flow can be attained by the size reduction by reducing the particle size. It is mostly applicable for the powder material when it is to be filled into dyes during compression of tablets. Next advantage, effective extraction of drugs. So during extraction process we know that menstruum is used. Menstruum means the solvent which is used for extraction purpose. So here if the particle size is small, menstruum will penetrate very easily and leaching or extraction of the active constituents will take place very rapidly. While as if the particle size is large, menstruum will not penetrate rapidly and therefore very slow extraction or leaching of the active constituents will take place. Examples of extraction: extraction of insulin from pancreas, and another one example, extraction of neem extract from neem leaves. Next advantage, effective drying. We know very well that rate of drying is more for smaller particle than larger one. Here you can see this is a larger particle which undergoes size reduction to give rise few smaller particles. Means this large particle is having low surface area and after size reduction these formed particles or these fine particles will have high surface area. Definitely the rate of drying will be higher for these fine particles than this larger particle. This is due to the difference in surface area. So here you can see that the rate of drying will be more for fine particles which can be achieved by the process of size reduction. Next, improved physical stability. Generally we know that if the particle size is small, the physical stability of product will be more. So by taking the example of suspension, we can explain it very well. Suppose that this is the suspension with small particles. Its rate of sedimentation will be low because smaller particles are present, and therefore here the stable suspension will be obtained. On the other hand, if the suspension contains large particles, the rate of sedimentation will be more and more particles will be settled down to the bottom, and therefore hard cake may be formed in the suspension which leads to instability of suspension. Next advantage, improved dissolution rate. We know that if the formulation contains smaller particles, the rate of dissolution will be more. So by taking the example of tablet formulation, we can explain it very well. If the tablet is administered by oral route, it will first reach to the stomach, then it will be disintegrated, means intact tablet will be converted into small particles. If the tablet contains small particles, the rate of dissolution will be higher. On the other hand, if the tablet contains larger particles, the rate of dissolution will be low. So, based on the selection of particle sizes, here rate of dissolution is dependent. Next, improved rate of absorption. By taking the same example of the tablet formulation, suppose that if the tablet contains small particles, after a dissolution, it will be absorbed into systemic circulation. So here, if the particle size is small, rapidly it will be absorbed. So rate of absorption will be high. On the other hand, if the tablet contains large particles, so those large particles will take more time to absorb into blood circulation. Therefore, rate of absorption will be low. Means to absorb the drug into systemic circulation or blood circulation fastly, the particle size should be small enough. One of the example is given over here. Chloramphenicol having a particle size 50 micrometer shows higher absorption rate than that of the chloramphenicol having a particle size 400 micrometer. Now we will move on towards disadvantages of size reduction. First, drug degradation. During size reduction, heat may be produced and therefore it may lead to degradation of thermolabile drug. Means when size reduction takes place, heat generates, and due to this, thermolabile drug substances or heat sensitive drug substances may undergo degradation. Again, if the waxy material is there, such a material may be softened due to heating. That heat may be generated during again size reduction. So to prevent such problems, drug or powder may be chilled before size reduction. Next disadvantage, poor mixing. In size reduction, large size particles are converted into small size particles or very fine particles. So these very fine particles possess a cohesive forces which are very strong. So therefore, it may lead to aggregation. Aggregation means simply accumulation of similar particles, which leads to or results into improper mixing. Next, contamination. During size reduction, moving parts of the equipment may wear off the parts of equipment, which may cause contamination. So during milling, these grinding surfaces wear off. Wear off means simply a removal of fine particles of metallic surfaces of the equipment. That is nothing but wear off. So these metallic surfaces or metallic particles may contaminate the powder material. So this is also one of the disadvantage of size reduction. Next point, mechanisms of size reduction. My dear friends, here you can see the diagram. By using this diagram, we can explain the mechanisms or general process of size reduction. This is a unmilled particle. This particle possesses flaws. These are the flaws. Flaws means weaker area or weaker zone present in the particle. When impact is applied, these flaws develops into crack. These flaws develop into crack. On applying further impact, small particles are generated. Means this crack completely separate and smaller particles with additional surfaces are formed. That is called cleavage of particle. Again here the same mechanism is given by using the attrition. So this unmilled particle, when subjected to attrition, edges are broken down or surfaces are broken down to form the smaller particles. So here you can see different mechanisms of size reduction. There are mainly 4 mechanisms of size reduction: cutting, attrition, compression and impact. We will see one by one. Cutting. In cutting, the material is cut by means of sharp edges of instrument or sharp blades of the instrument. Okay, so here material is cut by sharp edges of the instrument or sharp blades of the instrument. In case of attrition, it involves breaking down the particles or material by rubbing action between two surfaces. By rubbing action between two surfaces. So it is a surface phenomenon. In case of compression, the material or particle is crushed between two rotating rollers. Two rotating rollers. So material or particle is crushed between two rotating rollers by applying a pressure. In case of impact, here it involves striking of rotating hammers on a material, which leads to splitting of the particles of the material. So friends, here you can see this table. This table explains each and everything regarding mechanisms of size reduction shortly. Here you can see this mechanism, then details, particulars if any, the example of equipment. First, cutting. As we discussed, in cutting, material is cut by sharp edges or sharp blades of the instrument. In attrition, material is broken by rubbing between two surfaces. Rubbing action between two surfaces. Then in compression, material is crushed between two rollers by applying a pressure. So that is nothing but a compression. In case of impact, material splits by the striking of rotating hammers. By striking the rotating hammers. So in case of cutting is mostly applicable to fibrous or waxy materials. In case of attrition, here by using attrition, very fine powder is obtained. In case of compression, it is applicable to hard material. In case of impact, it gives any type of powder. It may be coarse, medium or fine. So based on the type of mechanism, different mechanisms are given. Again, examples of the equipment are mentioned over here. Cutter mill involves the mechanism of cutting. Fluid energy mill involves the mechanism of attrition. Roller mill involves the mechanism of compression, and hammer mill involves the mechanism of size reduction, that is impact. Next point, laws governing size reduction. Here in laws, it generally explains or it accounts the energy requirement for size reduction. So when the process of size reduction takes place, at that time flaws develops into cracks and new surfaces are generated. So for this process, energy is required. So how much energy is required for size reduction process? That is calculated by different means. So here different laws are given. Laws of size reduction. First is a Kick's law, second Rittinger's law, and third Bond's law. These three laws are predominantly used for calculating the energy requirement for size reduction. So first of all, we will see Kick's law. Kick's law is based on ratio of size changes in material. Size changes means initial particle size and final particle size. Initial particle size means particle size before size reduction, and final particle size means particle size after size reduction. So the statement of Kick's law is the energy required for size reduction is directly proportional to the ratio of size changes. Energy required for size reduction is directly proportional to the ratio of size changes. So by using a mathematical equation, we can state it in this way. E is equal to Kk natural log of di upon dn, where E is energy required for size reduction, Kk is a Kick's constant, then di average particle size before size reduction, and dn average particle size after size reduction. Next, Rittinger's law. So it is based on change in surface area of material. Change in surface area of material. Definitely, initially the surface area will be less, and after size reduction, the surface area will be more. So here, according to this Rittinger's law, energy required for size reduction is directly proportional to the new surface area produced. Energy required for size reduction is directly proportional to the new surface area produced. So mathematically we can explain it. E is equal to Kr in bracket 1 upon dn minus 1 upon di bracket complete, where E is equal to energy required for size reduction, Kr Rittinger's constant, Di average particle size before size reduction, Dn average particle size after size reduction. Next, Bond's law. It is based on new crack length produced. Initially, we discussed a particle possesses few flaws on the surface. Flaws means weaker area or weaker zones. On providing impact, these flaws develops into crack and crack length is produced. So on that, this Bond's law is based. So here we can give the statement for Bond's law. Energy required for size reduction or crack propagation is directly proportional to the new crack length produced. Once again, I am going to repeat. Energy required for size reduction or crack propagation is directly proportional to the new crack length produced. Again, mathematically we can explain it. E is equal to 2 kb in bracket 1 upon under root of dn minus 1 upon under root of di bracket complete, where E is equal to energy required for size reduction, kb Bond's constant, di average particle size before size reduction, and dn average particle size after size reduction. So on the basis of this session, I will give few assignments to the students. First, define size reduction, explain its advantages and disadvantages. Second, explain in detail mechanisms of size reduction. Next, write a short note on laws governing size reduction. For the study purpose, students may prefer Pharmaceutical Engineering by C.V.S. Subramaniam, then a practical book of Pharmaceutical Engineering by Dr. Suresh G. Sudke. Then this is the website from which I have taken few diagrams. Finally, I would like to appreciate and thanks to all the coordinators of E-Content Development Committee organized by Dr. Babasaheb Ambedkar Technological University, Lonere, to provide online platform for students to easily access data during pandemic COVID-19. So once again, thank you very much. All the best.